So an airplane with an airspeed of 600 kilometers per hour and a bearing of 70 south 30 degrees east. So if I draw a picture, this is 30 degrees, south 30 degrees east, so the whole angle here is 270 plus 30, or 300 degree angle. The wind velocity, and this is 600, the wind velocity is 40 kilometers per hour in south 45 degrees east. So this is here, that's 315, and that's 40. And I want to find the resultant vector. So the plane is 600 times cosine of 300 degrees I plus sine of 300 degrees J. And the wind is 40 times the cosine of 315 degrees I plus sine of 315 degrees J. So I want to figure out they are. The cosine of 300, that is 1/2. The sine of 300 is negative radical 3 over 2. The cosine of 315 is radical 2 over 2, and sine is negative radical 2 over 2. So this is 300 I minus 300 radical 3j. And this is 20 radical 2I minus 20 radical 2j. So if I'm going to add them together, I want the resultant vector, I have to add the two together. So I have 300 plus 20 radical 2I minus 300 radical 3 plus 20 radical 2j. So that's my resultant vector. I want to know the ground speed, that's the magnitude of this, which is the square root of 300 plus 20 radical 2 squared plus 300 radical 3 plus 20 radical 2 squared, the whole square root of that. And if I calculate that, that's 638.7 kilometers per hour. Now I want to know the direction. Well, if I want to know the angle between two vectors, the angle is the inverse tangent of the j coordinate over the I coordinate, because it's delta y over delta j, delta y over delta x. So theta is the inverse tangent of negative 300 radical 3 minus 20 radical 2 over 300 plus 20 radical 2. And when I find that angle, it's negative 59.1 degrees, and so I want to know that's this way, right? And I need to know what this angle is. So 90 minus that, or 90 plus that, gives me south 30.9 degrees east. That's my speed, and that's my direction, because it's 59.1 this way, and I need to know what this little direction is here from the south to the east.